Hello students! In our previous video, we have studied what are conditions of similarity of triangles. Now in this video, we will study the Basic Proportionality Theorem or BPT. Students, this theorem is very important theorem as throughout the chapter we are going to use this theorem to prove all other theorems. BPT is also called as Thales Theorem. The statement of theorem says if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So students, here we are given that there is a triangle ABC. There is a line L which is parallel to side BC of triangle ABC and it intersects at point D on side AB and at point E on side AC. So what we have to prove is that AD upon DB is equal to AE upon EC. In simple words, which means that when line cuts both these sides, it divides both the sides in equal ratio. Student, to prove this theorem, we will have to do some constructions. So let's do it then. First join points CD and BE and observe it forms two triangles. Now with the help of construction, draw two perpendicular lines from point E to the side AD and from point D to the side AE of the triangle ADE. Note students, here the triangle is triangle ADE. But how will you draw these perpendiculars? Do you remember? I'm sure you must. Let's recall it. To draw these perpendiculars, take a compass and make a semicircular arc as shown on the side AD with a small radius. Now with this same radius, draw arcs from point of intersection I1 and I2 as shown. Now name the point Q where both these arcs intersect. Draw a line from E, that is the vertex of a triangle, to this point of intersection Q. The point where this line intersects the side AD, it is a point F. And this line EF is perpendicular to side AD. So similarly draw perpendicular DG to the side AD from D. Therefore, now we have EF perpendicular to AD and DG perpendicular to AE. Now let us move to our theorem and prove it. Students, here we are given a triangle and a line which is parallel to one of its sides. And we are asked to prove that two other sides where this line intersects are divided in equal ratio. So let's see the proof. Observe the figure formed after doing construction. How many triangles do we observe? Yes, there are many triangles. But for our proof, we will consider three triangles, namely triangle ADE, triangle BDE, and triangle CDE. Now let's find out the areas of these triangles one by one. We know that area of triangle is half into base into height. Recall students that height of a triangle is nothing but a perpendicular drawn to its base. Also recall that we denote area of triangle as AR into bracket the name of triangle. So, area of triangle ADE is equal to half into its side AD and perpendicular EF that we constructed. Or for the same triangle AD, I can also write its area is equal to half into AE, its other side, and DG, which is perpendicular to that side. Similarly, area of triangle BDE is half into BD into EF, and area of triangle CED is equal to half into CE into DG. Now you must be thinking why we have used here EF and DG. Observe carefully, students. For these triangles, EF and DG are perpendiculars, which gives their height. Students, we want to prove that ratio of sides are equal. So what do? Yes, simple. We take the ratio of areas of respective triangle. Therefore, we get area ADE upon area BDE is equal to half into AD into EF upon half into BD into EF, which gives us AD upon BD. Similarly, on taking ratio of triangles ADE and CED, we get area of ADE upon area of triangle CED is equal to AE upon CE. Now students, observe that triangle CED and triangle BDE are two triangles with same base DE, and they are between two parallel lines, that is line BC and L. Recall that the area of triangles having same base and between the same parallel lines are always equal. This we have studied in our previous classes. So we can say that here area of triangle CED is equal to area of triangle BDE, as they are triangles with same base DE and between two parallel lines. Now replace BDE with CED and observe that both the equations become same. So our equation 1 is area ADE upon area CED is equal to AD upon BD, and equation 2 is area ADE upon area CED is equal to AE upon CE. Thus, we can equate 1 and 2 and say that AD upon BD is equal to AE upon CE. So students, we have proved that if line is drawn parallel to one side of the triangle such that it intersects other two sides in two distinct points, then it will divide these two sides in equal ratio. Here we have proved that ratio of AD upon BD is equal to AE upon CE when line L is parallel to the side BC of triangle ABC. This theorem is called as Basic Proportionality Theorem, which is also known as Thales Theorem. But students, if I ask you that ratio of AD upon AB and AE upon AC is also proportional, let us answer. By BPT, we already have AD upon DB is equal to AE upon EC. Now students, reverse this equation. We get BD upon AD is equal to EC upon AE. Now add 1 to both sides of equation. We get DB upon AD plus 1 is equal to EC upon AE plus 1. Take LCM of both sides and we get DB plus AD upon AD is equal to EC plus AE upon AE. Now observe our triangle. DB plus AD is equal to whole side AB. Similarly, EC plus AE is equal to the whole side AC. Therefore, can we write DB plus AD as AB and EC plus AE as AC in our equation? Now again reverse the equation and we get AD upon AB is equal to AE upon AC. By BPT, we can say that when parallel line cuts two sides of a triangle, it divides it in equal proportions. And this proportionality holds true for all three cases. That is AD upon DB is proportional to AE upon EC, or AD upon AB is proportional to AE upon AC. Similarly, DB upon AB is proportional to EC upon AC. This was BPT. But is converse of BPT true? That is, if we are given that sides are proportional, then can we prove that the line cutting two distinct sides is parallel to the third side? We will see in our next video.